Hello everyone, welcome to Physics Mastery Academy. 2-point charges, each of charge q, are fixed at the ends of an insulating rod of length 2L in the xy plane. The rod rotates counterclockwise about the z-axis with an angular speed omega, as shown in the figure. Determine the magnetic dipole moment vector of this system. This system behaves like a current loop, where the two moving charges, this one and that one, create a circulating current, as shown by I, which produces a magnetic moment along the axis of rotation. Here, the rotation is in the xy plane, like this, and the direction of magnetic dipole moment can be found by right-hand rule. If we bend our four fingers in the direction of current, as you can see, these four fingers, our thumb shows the direction of magnetic dipole moment vector. In this case, this vector is in the z direction. And remember that direction of current is the direction of positive charged motion. The magnetic dipole moment vector, that we show it as mu here, can be calculated by I times A for this electric system, and as discussed, the direction of this vector is positive z direction. So I is this current and A is the area for this loop. We need to find these two to find mu. I is the ratio of charge per cycle to time per cycle. In other words, 2q over t. T here is actually the period of this motion. We can find t using the definition of omega, which is 2 pi over t, and therefore t becomes 2 pi over omega. If we substitute t in this equation after simplification and cancelling out 2, we get q omega over pi for the current. Now we need A. For the circle, it's pi times radius squared. Radius in this circle is L, therefore area is pi times L squared. If we replace I and A in mu, we get this, that after cancelling pi, we get mu as q omega L squared in positive z direction. Therefore, C is the correct answer for the magnetic dipole moment vector of this electric system. Thanks for watching.